11.3 Geometric Series and Sequences. Right, we skipped over 11.2. 11.2 was arithmetic sequences and series. To be able to determine if something is arithmetic, what you do is you do the common difference. Find if there's a common difference between the numbers. Like for instance, what I mean by common difference is if we look at example 1, if I subtract 2 minus 1, I get 1. And then 6 minus 2 would be 4. Well, if this was arithmetic, those numbers would all be the same. And what it does is when it's arithmetic, it tells you that it's in y equals mx plus b. So you can just use the y equals mx plus b form to find an arithmetic series. All right. But now geometric series is a little different. All right. Geometric series, what you're going to do is to determine if it is a geometric sequence, what you're going to do is see if there's a common ratio. All right. To find out if there's a common ratio, we take the first one and divide it by the second one. Or, yeah. So it would be this one divided by this one. So 2 divided by 1. And that's equal to 2. All right. And then we try the second, the third, and the second. So we do 6 divided by 2. And that equals 3. Well, we can stop right there. Because if this was geometric, these numbers would be the same. All right? They would all equal the same thing, and that tells you that it would be geometric. So this one is no. It is not geometric. All right? So now we look at this one. If we do 27 divided by 81, all right, that actually reduces to 1/3. If we do 9 divided by 27, that reduces to 1/3. If we do 3 divided by 9, that equals 1/3. And then we do 1 divided by 3, and that's 1/3. All right, so you see we're getting the same number here every time. So that means that it is geometric. So yes, it is geometric. And this number that we're getting every time, that is called the common ratio. All right, so the common ratio is 1/3. We're gonna need that for the formula we're gonna get for this. All right, so the answer is yes, and the common ratio is 1/3. All right, so if you want to do the U-tries real quick, you can pause the video. All right, and do it. I'm just gonna do it real quick. So this one, just to give you the answer, 24 divided by 6 is 4. 96 divided by 4 is 4, and 384 divided by 96 is 4. So the answer here is yes, this is geometric, and the common ratio is 4. All right. B, we do 13 divided by 4. It doesn't simplify. 22 divided by 13. That doesn't simplify either. So these two are not the same. So this one is no. All right. All right. And then we talked about this, the constant ratio that we're getting. This is called the common ratio. And they use it in the formula. They denote it by the letter R. All right. And that's going to be helpful because now we have a formula for finding the rule for a geometric sequence. The nth term for a geometric sequence with the first term a sub 1, that's important. The first term is a sub 1 and a common ratio of R. All right, there's our common ratio. This is the formula. A sub n, that's the number for any of the numbers, equals a sub 1. So this is the first term. R, that's the common ratio to the n minus 1. Okay, so we are going to use this to be able to write a rule. All right, so how this works is this way. All right, we're going to write the rule for this nth term of this sequence. And then we're also going to find a sub 8. It also wants us to find a sub 8. All right, so the first thing we do is get the common ratio. So negative 12 divided by negative 8. Both divisible by 4. Negative divided by negative is a positive. So divide them both by 4 and we get 3 over 2. Negative 18 divided by negative 12, both divisible by 6, we get 3 over 2. And then negative 27 divided by negative 18, both divisible by 9, and we get 3 over 2. So we can see our common ratio is 3 over 2. So R equals 3 over 2. And A sub 1, the first term in the pattern, is negative 8. So now we can write our rule. Our rule is this. A sub n equals A sub 1, which is negative 8, times the common ratio, which is R, which is 3 over 2, to the n minus 1 power, and that is the rule for that pattern. All right, now we can use it to find A sub 8. All right, and that just means that to get A sub 8, we plug an 8 in there. So we got negative 8, 3 halves to the 8 minus 1 power. So that gives us negative 8 times 3 halves to the 7th power. And again, I'm just going to use the calculator, all right, for that one. So again, I'm going to start here. I can just put the whole thing in if I want, but I'm going to do 3 divided by 2 to the 7th power, hit enter, and then times negative 8 and hit enter. Now you'll notice I get a fraction or a decimal. I'm going to change that into a fraction, all right, and do that by hitting math. And the first one in math is fraction, so I hit enter and it changes my answer to a fraction, which is negative 2187 over 16. All right, so that is A sub 8. All right, so here's a U-try for you to do. All right, so you're gonna go ahead and do the U-tries. Pause it if you want to, and then I'll give you the answers for them. All right, so for the first one, A sub 1, you can see is 5. And R, in this case, was 2. So, A sub n equals 5 times 2 to the n minus 1 power. That is your rule. And A sub 8 equals 640. All right, the second one, A sub 1, we can see is negative 3. R, common ratio, is negative 2. So our rule, A sub n equals negative 3 times negative 2 to the n minus 1 power. All right, so there's our rule. And A sub 8 in this case is 384. All right, we're going to skip this part and skip that part. All right, so we're skipping example 3. We're going to skip this whole page. All right, this whole page we're skipping, and we're just going to go right to the using it in real life. All right, so just going to do example 5 with you. So it gives us this information for a cell phone service. So in 1990, the average monthly bill was $80.90. From 90 to 97, the average monthly bill decreased by about 8.6% per year. So this rule is actually something we were just working with. This is an exponential decrease model, but it's also one of our geometric series. All right, so this one, A sub 1 is $80.90. All right, and the common ratio in this case is 1 minus 0.086. again, we change this to a decimal, 0.086, and we subtract it to 1 from 1 to get the common ratio. All right, so it's going to look like this. A sub n equals A sub 1, which is $80.90, times, and we do 1 minus 0.86, 0.86, and that gives us 0.914. So R equals 0.914. And that's to the n minus 1 power. Right? So that's how you write the rule, and this is a real life model to see how it's actually used. Just remember, this said decreased. If that would have said increased, then this would have been plus 1 plus. Right? So this was n equals 1 is 1990. So n equals 2 is going to be 91. N equals 3, 92. N equals 4 would be 93. So this is n equals 4. And I'm just going to do this one. So we have that n equals 4. All right. So we're going to just find a sub 4. And that is going to be 80.90.914 to the 4 minus 1 power. All right. And again, we're just going to put that in the calculator. So I'm going to 4 minus 1 gives me 3. So we got 0.914 to the 3rd power, hit enter, and then times 80.9, enter, and I got $61.77. So in 1993, the average monthly cell phone bill was about $61.77. All right. So that's it for the notes. We're going to stop right there. You can do the U-tries if you want. If you're doing this last problem, wants to know when it dropped down to 50. So what we would do is we would put the 50 in for the a sub n. So it would look like this. 50 equals 80.90, 0.914 to the n minus 1 power. And then you would just have to solve that equation in order to find that answer. All right. I'll send you out what the homework is.